So the first one is expander brakes. As I told you, they all work on mechanical force. Whatever force is applied through the pedal, that will be magnified with the help of linkages or sometimes through the cables. In cycle you might have seen a cable. Okay, so this is a cam operated and this is a toggle lever. So this is called as a toggle lever. You can see a structure like this. Okay, this structure, whatever you can see, this is called as a toggle lever. Okay, so this is a toggle lever structure. The brake will be applied through this structure. So it is called as toggle lever operated. Okay, so whenever you apply a brake, okay, say for example, we'll consider the example of a bicycle only. So whenever you apply a hand brake, what happens? The whatever cable is attached, that will pull this lever towards this direction. So what happens to this? The toggle lever axis is vertical now. So when this is pulled, the axis becomes horizontal. So the toggle lever position changes to horizontal like this. So what happens when it changes to horizontal? So these whatever drums you can see, two drums will be pushed away from each other. Okay, so this is the wheel, this is the brake shoe, and this is the brake liner. You have studied this in drum brakes. So this is the brake shoe, brake liner, and this is the wheel. So whenever this toggle axis becomes horizontal, okay, these two brake shoes will be pulled away each from each other, so that the braking force will be applied. Okay, and there will be a retracting spring. What is the function of this spring? Whenever you release the brake, its axis becomes normal. So because of the tension in spring, complete relaxation from the brake will be there, so that the vehicle can move normally. If the same function, instead of a toggle lever, if it is done by a cam, you can see a cam, it is like a oval egg-shaped structure. So whenever there is a pull from the brake wire, so this axis changes to horizontal from vertical. Okay, so that the brake will be applied. See, the principle of working is similar to drum brakes. Only thing is, instead of a fluid here, a cable which will apply a mechanical pressure will be the acting person here. But the thing is, it is suitable only for low speed vehicles. Yeah, because the intensity of braking will be less, right? So for high speed vehicles, you cannot rely, because for high speed, the efforts required by the driver will also increase, and it is practically not possible. Okay, so the principle of working of both the systems are same, but one is operated by a toggle lever, the second is operated by a cam. That's all. Is it clear? Any doubts in this? Yes, someone can unmute, and if you have any discussion, otherwise we'll move to the next. Next, Girling mechanical brake. Is it clear? Any doubts? Ashok? Praveen?
No, sir.
Ashok?
Yes, sir.
Ashok IS.
Praveen, sir. Praveen.
Okay. Ashok? Akshay?
Yes, sir.
Shiv Prasad?
Yes, sir.
Okay, so the next concept is Girling mechanical brake. Just take down the sketch. It is almost similar to a drum brake arrangement, whatever we have discussed earlier. Girling mechanical brake. All of you unmute. Sorry, mute yourself. Okay. So Girling mechanical brake, right? So here there are two important components. One is the expander unit. This is the expander unit and this is the adjuster unit. So this is the expander unit and this is the adjuster unit. So this is the wheel, brake shoe and brake liner. I'll repeat once again. This is the brake shoe. Okay, so this is the wheel. Okay, so this actually is the wheel. This is the brake shoe, brake liner. Okay, two important components are, one is the expander unit and the adjuster unit. Whenever the brake is applied, okay, so this expander unit will move up and this will push these two, okay, in the reverse direction. So that what happens, whatever these brake shoes are there, they will be pushed away from each other, so that this brake pad will directly come in contact with the wheel and the brake will be applied. Whenever the brake is released, it comes back to its original position and these two brake shoes will be retracted back. So this is the mechanism of working. It is similar to the whatever drum brake we saw. Here, what is the function of adjuster unit? It can be adjusted over a period of time. What happens? There will be a wear and tear of this brake pad, so that you can adjust the brake shoe position. By operating it, you can move the brake shoe a little bit ahead, so that whatever wear and tear is there, that can be compensated up to some extent. After that, the new pad has to be inserted here in both the places, and you can reset back the adjuster unit. So for ensuring the maximum utilization of the brake pads, this adjuster unit will be adjusted. So it is an additional mechanism. So the working is almost similar to that of the whatever drum brake we have seen. So the same thing I have explained here. Okay. So coming to the next concept, servo brake systems. Okay. So what do you mean by servo brake system? So any mechanism which supplements the driver's effort in applying the brake. See, if a driver applies small amount of pressure onto the pedal, it should be magnified number of times and the brake should be applied effectively. Okay, so the mechanism which magnifies the driver effort is called as a servo brake system. I'll repeat once again. Any mechanism which supplements the driver's effect in applying the brake is termed as servo mechanism. Okay, so braking effort increases with weight of the vehicle. See, this we have already discussed. Okay, so mainly we discussed three types of braking. One is the hydraulic braking, pneumatic braking, and the mechanical braking. So as I told you, mechanical braking, you cannot use it in a car or a truck because the amount of effort required will be very huge and it will be almost impossible. Correct. So whereas you can use it for a bicycle. Okay, it's lightweight, load applied will be same. So similarly here, braking effort increases with weight of the vehicle. After a particular limit, it becomes very difficult for the driver or impossible to apply the brake. Okay, in such cases, a servo action or self-energization action will be given by the servo brake systems. Okay. So a small amount of pedaling effort, it will be multiplied number of times and the brake will be applied. Just imagine a huge truck with a very huge amount of load, tons together of load. By just pressing a pedal, if it has to stop, what should be the number of times the effort is magnified? Okay, so the magnification of the effort will be done by this servo brake system. Okay, so usually vacuum servo brakes will be used. One of the example I can quote here: if you travel in a Volvo bus, very now and then you can. If you sit at the rear especially, you can just hear the noise of air being discharged. Okay, just notice it when you travel next time. Air will be very frequently discharged. Okay, so that is the common characteristic of vacuum servo brakes. Okay, in the next slide we will just study the circuit and the mechanism. Okay, so a small vacuum reservoir will be provided. Okay, so that which will be holding the brake in certain position. Whenever you apply the brake, this vacuum will be released so that the brake will be magnified like anything and the brake will be suddenly applied. Okay, so this is called as vacuum servo brake. With the help of this sketch, we can clearly understand the principle. Take down a very neat sketch because it is a 10 to 12 mark question. Okay, take down a very neat sketch.
Sir, one doubt, sir.
Yes, please.
Sir, trains ಅಲ್ಲಿ ಯಾವ ತರ ಬ್ರೇಕ್ ಸಿಸ್ಟಮ್ ಯೂಸ್ ಮಾಡ್ತಾರೆ ಸರ್?
Usually pneumatic only.
ಓಕೆ.
Take down. Is it done?
Sir, 2 minutes, sir. Sir, completed, sir.
Okay, please listen. Is it audible?
Yes, sir.
Yes, sir.
Okay. So this is an example of a vacuum servo brake. Okay. So the name servo brake is given because, as I told you, it energizes the braking system. Okay. Vacuum is the word used because the vacuum is a thing which energizes the system. Actually, here. Okay. So this is the master cylinder, as we discussed. Okay, this is the main core component, braking pedal. This is the brake fluid. So it works on the principle of hydraulic braking example I have taken here. So whenever you press the pedal, what happens? The fluid will be pushed through this cylinder. Okay, so that this piston moves up. Please observe carefully. So this is a vacuum chamber. So this is a vacuum chamber where there will be some vacuum. You can see that this chamber is directly connected to the vacuum reservoir. Okay, so that this will be under vacuum. Yeah, so that what happens here, suction takes place and the piston will be locked at this position. Are you understanding? So here a complete vacuum will be there, so that the piston will be sucked and kept at this position. So again I repeat, there will be a negative pressure here, so that it will be sucked and kept in position. Okay, first point is very important. Next, the second point is, whenever you apply the brake here, what happens? Through the master cylinder, the fluid will be pumped into this secondary cylinder, to this cylinder. So what happens here? This piston will come and seal down at this point. This piston will come and seal down, and this piston moves up. So when this moves up, so this portion, whatever control unit is there, it will be exposed to the atmospheric pressure. So here you will be having atmospheric pressure. Are you understanding? Atmospheric pressure, which is higher than the vacuum pressure. So what happens? Here you have a higher pressure. Okay, here you have a vacuum. So you can see this portion is directly connected to the vacuum reservoir. You have a negative pressure. So the piston will rush like anything onto the outer side. So this will be in turn connected to the rest of the wheel cylinders. There will be a distributor and 4 wheel cylinders will be there. As we discussed yesterday, there will be 4. So immediate brake will be applied. Now, whenever you release this valve, what happens? This will come and sit back in its position. Again, vacuum will be created so that the piston will come back. Please just think over any doubts you can ask me. It is all a simple mechanism which works on pressure difference. Whenever you press the pedal, this portion will be open to atmosphere. Okay, so here atmospheric pressure will be there. That is 1 bar pressure will be there. So the second side, so I'll take this as 2 and this as 1. The second side will be under vacuum pressure. The first side will be under atmospheric pressure. Correct? So that here pressure will be more. The piston will be pushed rapidly outward, so that brake will be applied. Whenever you release the pedal, again what happens? The liquid will be taken back by the master cylinder. So again this portion will get sealed up. Here already it is connected to vacuum. Here you can see vacuum will be created, so that this plunger pushes back the piston to its original position. So this is the working of a vacuum servo brake. Any doubts you can ask me. It's a very simple mechanism.
No, sir.
Okay. So we are at the end of the second module, that is brakes. The last topic left is very interesting, anti-lock braking system, ABS. Have you heard of it?
Yes, sir. In bikes, cars.
Yes. In cars also, when you buy a brochure, so anti-lock braking in old cars, this mechanism was not there. I can quote two important examples here. Whenever the road is slippery, if you apply the brake, sometimes car will skid over. Okay, immediate brake will not be applied. The wheels will be locked and car will be moving. It will be skidding. You can see a black color line on the road, correct? Because of the tire being skidding on the road. This is first. Second, many times cars topple. Okay, ulta ಹೊಡೆದು ಬಿಡುತ್ತೆ. Why that happens? Okay, if this anti-lock braking system is not there, such issues will be there. Okay, so locking of wheels takes place due to excessive braking, and that will either cause skidding or toppling of the vehicle. Okay, how I will explain you in detail. Skidding can be avoided by releasing the braking pressure just before the wheels get locked. Okay, I'll just give you a simple example over here. Say, for example, you have a curvy road like this. You imagine a curve like this. So the car is moving at very high speed. Whenever you notice the curve, suddenly if you apply the brakes, what happens? See, I'll take this as the center point. Okay, your car is in this position. Okay, so this is wheel 1, wheel 2, wheel 3, and wheel 4. Just try to understand. This is your car, and 1, 2, 3, 4 I have named. The radius of curvature of inner wheels is lesser, whereas the radius of curvature of outer wheels will be very much more. When you apply a brake, the inner wheels will suddenly get locked, whereas the outer wheels will be still moving. When these wheels get locked, what happens? There will be an undue pressure applied, so that this 1, 2 region will be locked, 3, 4 will lift up, so that your car will be toppling. Think and tell me whether this is correct or not. Are you understanding?
Yes, sir.
ಅರ್ಥ ಆಗ್ತಾ ಇದೆಯಲ್ಲ? If it is a flat road, so what happens when you are moving through the car? When you apply the brake, the 1, 2, and 3, 4 wheels will be at the same radius of curvature, or 4 wheels. So equal braking will be there. Brake, the car will stop, or sometimes if it is high speed, it will skid for a while and it will stop. If it is a curvature, the inner wheels have lesser radii, it will be rotating at lesser RPM. Outer wheels are having higher RPM, so that what happens here, the braking effort will be lesser to stop. Here it will be more to stop. So these two wheels will get locked first, whereas these two wheels will be moving. Immediately your car will topple. Okay. If an anti-lock braking system is there, depending on the RPM of the wheels, it will distribute the braking force, so that lesser force will be given to wheels 1 and 2, more force will be given to 3 and 4, so that in the curve, without turning, your car will stop at that exact point. This is the concept of anti-lock, or sometimes it is called as EBD, electronic brake distribution. Okay. So the main concept here is it performs the pressure modulation, that is averaging the pressure, uniform distribution. How many times? 15 times per second it will check the pressure to the wheels that is applied, so that it will never fail. It will be such a accurate mechanism. Okay. Anti-lock braking system is an automobile safety system that allows the wheels on a motor vehicle to maintain tractive contact with the road surface. So all 4 wheels should maintain a contact with the road surface. Okay. If they don't maintain, what happens? The vehicle will either skid or topple. Okay. So it will generally improve the vehicle control and decreases the stopping distance. Okay. On loose surfaces like snow-covered roads, ABS can significantly increase the braking. Okay. So this is the operation procedure, right? You just notice this sketch. Okay. Yeah, as I told you, if it is a flat road, it will not be a problem. If it is a curve road like this, okay, it will be a major issue. We'll try to understand with the help of this video. You can go through this video. Gives you the ABS demonstration. Are you able to see?
Yes,
Yes,
sir.
sir.
Yes, sir.
Yes, sir.
See, the first vehicle was with ABS, and it is a snow-covered road. When you applied the brake, it stopped, whereas non-ABS moved towards the side because of skidding. Again, braking distance. This demonstrates the braking distance. See, no ABS. You can see a black color scar on the road. With ABS, it will lock multiple number of times. At one time, it will not lock. It will release the pressure, apply, release, apply. That will be done 15 times per second. So that vehicle will immediately stop. One more example we'll just see. See, suddenly the truck changed the lane. If you don't have ABS, what happens? Okay, when you apply the brake, okay, either the vehicle will be pulled towards left or right because of skidding. Either you have to hit the other vehicles or the pavement on the road if you don't have ABS. Anti-lock brake has also one more advantage. While applying the brake, your steering will not get locked. If you see olden cars, if you completely apply the brake, your steering will be locked. You cannot steer the vehicle. But here, it will allow you to steer also. In a curve, along with braking, you can slightly steer also. You can see the other one. See, when there is no anti-lock brake, you cannot steer. The steering was locked when the driver is trying. Whatever sketch is there explained in the video, the same sketch I have put it down. There will be a ABS control module. There will be 4 wheel sensors. You observe this video carefully. 100 km/h speed. See. You can very clearly understand the vehicle with ABS could steer also. So they could avoid that obstruction, but without ABS, he could not steer, so that he hit that obstruction. Okay, so this sketch you can take down. So there will be a ABS control module. Okay, So there will be 4 sensors, the red color slots, you can see there will be 4 sensors, electronic sensors, which do just sense the speed, RPM of the wheels. Based on the RPM of the wheels, the brake force will be applied. For example, if this wheel is running at almost 10 RPM, if it is nearing to 0, brake only for this wheel it will be released, whereas other 3 it will be applied. Once it gains the speed, again it will be applied. So like this is called as a modulation of pressure. So that pressure modulation will happen 15 to 20 times in 1 second, so that your vehicle will not topple. Always there will be a contact with the road and it will stop immediately without skidding. So this is called as anti-lock braking system. A braking module will be there, brake control unit, and ABS module will be there to distribute this pressure. Okay, there will be speed sensors, separate speed sensors for each of the wheel. So this is how an anti-locking brake mechanism works.